How much more volume does the prism have than the cylinder? So you already know that the prism has more volume. You just need to find out how much more volume. Go ahead and work on that. What did we do? Yesterday we did cylinders. Today we're going to do a double lesson of spheres and cones. Double lesson of spheres and cones. So we're doing volume. On your formula chart, a cylinder and a prism have the exact same formula. Oh no. So let's find the volume of the cylinder since that one comes first. We learned cylinders yesterday. We know the volume is base times height, except the base is a circle. So we know it's pi r squared times the height. So we're going to find the volume of the cylinder, pi r squared h. So final answer, what is the volume of that cylinder? (612 pi inches cubed). Okay, now let's find the volume of the prism. It is base times height, but the base is a square. It's a 12 by 12 square. So 12 times 12 times 17. 144 times 17. Which one's bigger? I forgot. Which one did they say is bigger? It says how much more volume does the prism have? So we know that the prism is the larger one. So the answer to the warm-up is 2,448 minus 612 pi. Now, let's pretend this was a real-world problem, and you were going to store, like you were trying to buy canisters to store flour in for your kitchen, and you wanted to know how much more flour the prism would hold, and that answer isn't going to do you much good in the real world. So let's see what that would be in the real world. So we're going to actually subtract it, 2,448 minus 612 pi. So as a real world answer, it would be 525.3. That's how many more cubic inches the prism has in the cylinder. Okay? Good. Did you get a chance to check your homework answers while I was at the fire drill? Here's the homework answers in case people are watching the recorded lesson. You can press pause and look at the answers. Remember, we're going to do the evens on the homework for the rest of this unit, just so that the homework is shorter and it's more doable, more manageable, and you're not spending as much time at home. I don't think you needed to do all 18 problems. I think the odds would be good enough and you would know what you're doing if you did all of those odd problems. So 14 and 16 have already been worked on my homework help. It's a really short YouTube video, so I'm not going to work 14 or 16 because you can watch those. So check out the homework help if you want 14 or 16 worked. We're going to move on. We're going to teach, like I said, we're going to learn 2 lessons today. The reason we're able to learn 2 lessons is that the cone lesson is going to be very short and sweet. A cone is going to be just like our pyramid. So prism is to pyramid as cylinder is to cone. Or you could say that the prism is to the cylinder as the pyramid is to the cone, whatever analogy you want. But a cone is going to act just like our cylinder, except in the volume we're going to divide it by 3, right? Okay, so parts of a cone, just like a pyramid, it's going to have 2 different values for a height. It's going to have a height and it's going to have a slant height. This one's a little bit less complicated because there's no apothem involved. So the height, the slant height, and the radius, obviously, form a right triangle. So that is a fact. That is a right triangle, and we will use the Pythagorean theorem to find the missing sides. I'm not going to pour any more water, thanks for asking, because we've already done the investigation. And you can trust me that if 3 pyramids fit into a prism, then 3 cones fit into a cylinder. You're going to trust me on that one. No more water experiments. Okay, here are our formulas. Go ahead and write those down. Formulas for a cone. I'm not going to derive them because, like I said, we're short on time. So the lateral surface area is literally pi times r times L. If we're leaving it in terms of pi, all you're doing is multiplying r times L, the radius times the slant height. The surface area, you take the lateral area you already found, and then you just add a circle to it, because that's what total surface area is. It's the lateral plus the base. In a cone, just like in a pyramid, there's only one base. So the SA would represent the area of the orange. And then the volume, of course, base times height divided by 3, where the base is a circle. Okay. Those are all on your formula chart. Let's just dive right in. I'm not even going to give y'all time to think about it. I'll give y'all time to think about ones that are tougher. Let's just do this problem together. The radius is given. The slant height needs to be found with Pythagorean theorem. What is the slant height? Got it? Pythagorean triple. And the height was given to us. So, given, and then Pythagorean theorem. All right, the lateral surface area, pi r L. We're going to leave it in terms of pi, so we're really just doing 8 times 17. If I put 136 centimeters squared, will I get this problem right? No, sirree. Have to put pi or it is wrong. Okay, total surface area. So we take what we already found, don't find it again, plus pi r squared. So it's the LA plus pi r squared, which is the area of the circle. So 136 plus 8 squared. (200 pi) centimeters squared. And then the volume. Don't forget to divide by 3. So in the volume, it's the base. Oops, don't square pi ever in your life. It's the base times the height divided by 3. So we have 8 squared times 15, not 17, it's the height. 8 squared times 15 divided by 3. Basic application of formulas. Moving on. We love composite figures, don't we? Okay, what do you want to find first? I always like to find the volume first. Usually the volume is the easier of the two. Let's go ahead and dive into the volume of this figure. I like to lay out a plan. I am a planner. I don't like to just dive into something. I like to have like a method and a plan of solving. So the volume is pretty straightforward though. We're going to find the volume of the cylinder plus the volume of the cone. So the strategy here was not that enlightening, but it's good to write it down anyways. Okay, the volume of the cylinder. Base times height. That's all there is to it. Base times height. That's cool. The base is pi r squared. The height is 6. Okay, what about the volume of the cone? It is base times height. Don't forget, divided by 3. I'm going to give you a minute to find the total volume. Okay, so hopefully we're getting 150 pi plus 100 pi. For a total, we are allowed to add these because, oops, I got too excited on my pies. There we go. For a total of 250 feet cubed. Cool? Now let's do surface area. I would say the strategy on the surface area would be, let's see, we're going to find the LA of the cone, right? We're going to find the LA of the cone. Then we're going to find the LA of the cylinder, and then we're going to find, well, yeah, one base of the cylinder, or just the area of the circle. You could also think of this as finding the total surface area of the cone plus the lateral surface area of the cylinder. There is more than one way to approach it. So if you're approaching it differently, that's okay. The only thing you can't do is just find the total surface area of this and the total surface area of this. What surface area is, it's finding the area of what you can touch on the surface, whatever you can touch. I cannot touch the bottom of this or the top of this. So we would not want to include his base or his base. Does that make sense? Surface area is what's on the surface. It's what you can touch. I can touch one circle, one LA, and one LA. Okay. So if you phrased your strategy differently, that is okay. So the lateral surface area of the cone, we just learned that today. Pi R, what's L? The slant height, it's 13, because we had a right triangle. 5, 12, 13. Is that okay with everyone? So pi RL plus the lateral surface area of the cylinder. Okay, so that's 2 pi RH plus pi R squared. Remember, if you approached it differently, that is okay. We do need to all come up with the same answer, though. Let's plug all this in. Okay, type in what you got. Let's make sure we all got the same thing. Nice, pretty answer. This one was easier than the one we did yesterday. The surface area is 150 pi feet squared. All right, we're still going. We are going to skip this one so that we can learn spheres. It does say the surface area only, so we would just find the LA of the top, and then we would just double it, right? Because do you see how the top and the bottom are congruent? It's just a pyramid and a pyramid. So you would find the LA, and you would double it. All right, here we go, guys. Spheres. Our last official shape. So we have a basketball. We have the planets. They're kind of spherical. We've got Epcot. That's called the Hayden Sphere. It's in New York. It's a museum. It's really pretty. It's a sphere inside a glass cube. Really pretty. We've got marbles. Did I already say that? Okay. Let's talk about what the definition of a sphere is. A sphere is the set of points that are a given distance from a given point. So a circle is also the set of points that are the same distance from a point, except a circle is obviously just 2D. But a sphere is when you take a point and you pick a radius, 5 inches, you find every single point in the universe that's 5 inches away from that one point, and that will form a sphere. Spheres are my favorite. It's a collection of points a given distance from the center. Collection of points a given distance from the center. This is just good to know. I'm not going to test you over this, but I am just fascinated with it. I think it's so cool. So spheres are the most efficient shape in the universe. The most efficient. I love being efficient. I'm all about being efficient. They have the largest volume for the smallest surface area. It's like you're getting the most bang for your buck. So think about when you're blowing up a balloon. The volume is getting greater and greater. That's the biggest volume you can get with the smallest amount of balloon material. So like if you blew up a balloon and you blew it up into a prism, you're not going to get as much volume for surface area as you would get with a sphere. Nature is aware that spheres are the most efficient shape as well. Nature knows this. And spheres show up a lot in nature. Like when you blow a bubble, it doesn't turn into a cone when you blow a bubble. It turns into a sphere. Water droplets, a lot of times, are spheres. What else? So yeah, when you blow up a balloon, it naturally turns into a sphere. Where else in nature do we have spheres? Nature loves spheres. We have the planets. Oh, we have the pearls from the trivia. We have some flowers, a dandelion, berries. Berries are automatically spheres. Anyways, I kind of have a little thing about spheres. Just love them. Okay, the great news is there's only two formulas for spheres. We have surface area, total of course, and we have volume. There's no such thing as LA for a sphere. It doesn't have any bases, so it can't have a lateral surface area. No bases. So write these formulas down. 4 pi r squared, that is surface area, and volume. 4 pi r, that's hard to see, that's cubed. 4 pi r cubed over 3, or 4/3 pi r cubed. How do they derive? Okay, sorry, we're not going to watch the video clip. You don't need to write this down in your notes. I just want everyone to understand that a hemisphere is half of a sphere. So if you want to find the volume of a hemisphere, you just take the volume of the sphere and cut it in half. Same with surface area. You just cut it in half. So we might ask you to find the volume or surface area of a hemisphere, and you're just expected to divide by 2. Okay, let's do this. Example number 1. Let's plug into our formulas. Spheres don't have heights. They don't have slant heights. They don't have apothms. All they have is a radius. It's so cool. So what is the surface area? 4 pi r squared. It's kind of like saying 4 cubed, huh? Since that's the radius. What is, very good, Ganesh. 64 pi centimeters squared. And volume is 4/3 pi r cubed. Don't forget to cube. It's not squared, it's cubed, because volume is 3D. So we're going to do 4 cubed. Do y'all know how to do that in your calculator? Times 4/3. It's going to give you a decimal. When you divide by 3 and your numerator is not divisible by 3, your volume is going to be a fraction. So get used to the volume being fractions. That is what I want your answer to look like. Uh-oh, I did something wrong. Are we okay with 256/3 pi? Are you allowed to put 85.3? No, you are not allowed to put 85.3. And we don't mix fractions either. We're not going to do mixed fractions. We're going to do improper fractions. You could also write it like this. That would be okay to write it like that. You can put the pi to the side, or you can put it in the numerator. Just definitely don't put it in the denominator. Let's do one where we're working backwards. The volume of a sphere is 288 pi. Find the surface area of the sphere. So the key to this problem is going to be to find a radius. We need to find a radius. So we know that our volume, we know that 288 pi equals 4/3 pi r cubed. The first thing I would do is cross off my pi's, and then I would flip and multiply. I'm going to multiply both sides by 3/4. That way the 3's cancel and the 4's cancel. What is 288 times 3/4? So it's the same as doing 288 times 3 divided by 4, and you get 216. So 216 equals r cubed. What's the opposite of cubing something? Cube rooting. Cube root. The way that you cube root something is you go to math 4. So go to your calculator, math 4, and type 216. The answer is 6. So now we have our radius. Our radius is 6. Now we can find the surface area, 4 pi r squared. Final answer, 144 pi centimeters squared. That was a fun one. Okay, I think this is the last one. Is it? No? Okay. Remember, it's not the cones homework. Oh, yeah. We're only doing the evens. Your homework is only over cones. You'll do your spheres homework tomorrow. I'm going to work this problem, but if you need to leave, you can leave. Okay? I love real world problems, so I don't want to skip this one. The Earth's equator is 24,902 miles long. Now, what's an equator? Is that like the radius? Is that just the diameter? What is an equator? It's the perimeter. Pick a different word. Circumference. Very good. So that's saying that the circumference, is 24,902. The circumference. Find the surface area by assuming that the Earth is spherical. We are going to assume it's a sphere even though it's not a perfect sphere. So, how can we get the radius? Pi's don't cancel. Do you see how there's no pi in my circumference? So we can't just cancel the pi's out like we normally do. We have to divide both sides by 2 pi. We have to divide both sides by 2 pi. Make sure you put that in parentheses. 24,902 divided by, parentheses open, 2 times pi, parentheses closed. So please make sure you use parentheses. Oh man, you totally can't see it. Anyways, I got 3,963. So that would be the radius. If we wanted to find the surface area, then we would do 4 pi r squared. So quite a large number. So we will square that times 4. Quite a large number. You getting it? Well, the Earth is huge, so the surface area is going to be huge. I'm just going to say 62.8 pi million. And we're going to call that a day. Real world problems are fun until you try to find the surface area of the Earth. Okay, have a good evening and do the cones homework evens. Thanks, guys.